Welcome to the following offering from the Webster Education Crash Course Series. This offering is composed of recorded materials from a live Webster Education class. For more information, please visit us at ibm.com/webster/education.
Okay, in the SOA overview, we're going to talk about what's going on with SOA and how we're evolving into it, and something called service-oriented integration and how that fits to SOA. We'll describe IBM's solution to SOA, and they do have their own view of what this is. We have a life cycle I'll introduce, and we'll talk about governance and the governance life cycle. This is a pretty good slide. We see this in a couple of our classes. Anybody worked in a application like what's being represented up above in a sequential one interface file to the next step? These would traditionally be, my days, they were mainframes, and we actually had tape files that we were passing from one process to another. One sequentially fed another into the next, and eventually the blue application would feed into the orange application on a multi-channel retailing application like that. That's no longer true. We actually have very tightly integrated applications that go across multiple areas. And so a more realistic view of applications now in the 21st century is we have a store or brand function that is using a shared service that then calls back into some store function that has an interaction with a customer that then goes out to a supplier, and even the supplier could outsource a function and come back into that orange application. And you can see that these things, even though it's got the same functionality, is actually distributed and has a lot of organizational boundaries and even outsourced partners, whatever you want to call them. We can no longer all run those on a mainframe passing tape files back and forth like when I started. And this, at the same time, we have a great need for a lot of flexibility and wanting to be able to change when actually we've made things more complicated. These interfaces and this connectivity between each one of those functions, because they're distributed, we're actually slower than we ever were, and we have to test them more carefully than we did like in my days with the tape drives. So because we are distributed and globalized, if you will, we need to change our business processes faster than ever because we were reacting in a more competitive environment. We need more information available across ways that originally the functionality wasn't designed for that. There's surveys from the chief executive officers where growth is one of their top agendas, and we are still having trouble realizing reusability. We've been trying to do this since object-oriented days. We've got to stop rewriting the same applications over and over, the same functionality over and over. We still have a long way to go to reach that reusability goal that we've started with object-oriented programming, and these things just cost too much, and we don't have time to do that anymore. So we have to come up with reusability again. This diagram is actually a real system. I think it comes from a auto vendor. This is more the reality of what an integrated system looks like. Our blue application, our green one is talking to the purple one. Look at all of the interactions between these things. We can assume that's a class diagram. It could be just about anything. These systems are very tightly coupled. And I just noticed Tom's microphone is turned off. There we go. Well, did we design for this? No. That evolved over time. Each small incremental change was a legitimate need, but because there was a lack of any kind of business process standards on how things are done, the technology was used to implement very tightly coupled business processes in a lot of code, and we just created this knot. Also, our architectural policies were probably limited. And so here we have an SAP tightly coupled to a PeopleSoft, tightly coupled to something else. And we've purchased point-to-point applications supporting each line of business and then tried to integrate them across the entire enterprise. And that could be what that purple application is in the middle, and feeds into everything else. All right, so we have built a tighter and tighter coupling between these components, and our executives are saying they want to change things faster and be more adaptable at their business level, and their IT systems are actually constraining what they can do. And so we have introducing service-oriented architectures as a style to build applications and integrate them together. And the emphasis and focus is on assembly of applications and less on the actual implementation details of this. And so what we're saying is that SOA is a set of architectural principles and patterns. It's using open standards to represent these software services as services, the software assets as services. Of course, we have to be careful defining what a service actually is. And we're using open standard communication protocols for integrating these applications in a completely different way. So what I want you to get from that slide is SOA is an architectural style, not a programming paradigm, and it is open. We are sending XML in most cases across the world. So I can always tell when something is fishy when talking to people, and they're going to put the application that they're building on the SOA. The SOA is an architecture, it's a concept, it is not a running thing. So you could deploy something into the architecture, but to actually run something on the SOA is somebody's got a definition crisscrossed here. Now, you can certainly deploy something on the bus as a service, but be careful. The SOA is, and it sounds like you guys have a lot of background in architecture, so be sure to be careful with that. Because it's an architecture and a style and a principle and patterns, it's difficult to present software and software solutions without mapping them back to the architecture. So architecture becomes more important than ever. So we're going to represent all of these interfaces and how these applications get built together as services, and put off the actual technical implementation until the very last minute. And I kind of like this diagram. We're showing basically, it's kind of like a Rubik's Cube, one of those puzzles that you turn to get the colors to line up. And so we're representing that as a standalone legacy application. We're actually going to tear that thing apart. We're going to decompose it out into each one of those color-coded components and define those as services. I'll call them simple services or atomic services. These are reusable functional components, and then I'm going to put them together in unexpected ways. Each service will not know how it's going to be used.
To view the full version of this lesson, please visit the URL below.